So it runs on a concept called machine learning, which is just a fancy way of saying the way that we train machines to learn and adapt without the need for structured or predetermined inputs. So what that means is we can give it a scenario. We don't need to give it any context. It'll be able to understand the scenario, manipulate the data that it needs, understand what it needs to output, and then give us some kind of output that we desire. So that can be giving it a picture, asking it what is in the picture, it knowing, okay, it's got a picture, what it wants to give out, and then giving us a result that we expect at the very least. What's on the board at the moment is what we call a neural network. So it's basically a simulate of what the brain structure looks like. So we have neurons in the brain. We have thoughts that jump between neurons and go between different neurons to make thoughts and decisions and all that kind of thing. Very similar to how neural networks work. We'll have an input layer, which is basically where things come into the model. So that'll be the prompt, it'll be the question that you have. It'll be an image, it'll be audio data. It can be anything that you could possibly stick into this model. Then there'll be a number of hidden layers, and that's typically where our parameters sit. And the parameters I'll get into now, but they're basically weights that determine decision making. So if it's got a specific trajectory that's going on, it'll hit a node and say, okay, is this node the best probable answer? Yes, no, next one. Carry on until it gets to an answer at the end of the node, which is your output node. And the training that we spoke about basically trains those hidden layers to make the best decisions once data hits them. So we'll make as much of those hidden layers as we possibly can. The more hidden layers we have, the better at decision making this model will be.